Hello everyone. So today we are going to talk about a new group of world problems. They are somehow a little bit more challenging than the ones that we discussed last week. Recall that last week we talked about some really quite simple world problems. We only talked about two of them, and today we are going to talk three types of classic world problems. And as you will see, it's critical to stay very kind of just alert about certain relationships. So let's go. Usually, in many real world problems, we want to consider the relationship between two quantities. And those relationships can help us to actually ascertain what those quantities actually are. So, if you have two quantities that are related, how many relationships can you think of about those quantities? And assuming one is larger than the other, well, sometimes mathematically, this larger can include the case where the two are actually equal. So in that case, the two quantities will be the same. But for the purpose of those world problems, we usually will have the case where one is strictly larger than the other. So how many kind of relationships can you think of between those quantities? Well, apparently you can think about the sum of those two numbers, right? So if we call the larger number as large, here we denoted in this italic form large, and the other number is small, then we can get the sum or the total of the two numbers. So apparently that's a very important relationship. And then the second relationship would be how much larger the larger one is than the smaller one. So in that case, we will get the difference between the two. Those two relationships are very fundamental. And usually, if we know both the sum and the difference, we can figure out both of them, both the larger number and the smaller number. And we will see that's a very classic type of world problems. And there's another relationship. And this only happens when the larger number is exactly an integer multiple of the smaller numbers. Let's just say if the larger one is 3 times of the smaller number, or just twice, or maybe 5 times. So in this case, there's a multiplicity relationship between the two. And this multiple equals to if we divide the large number by the smaller number. It happens to be an integer. The result is an integer. In other words, in many kind of those problems, there's no remainder. So today we're gonna consider various word problems in which the interaction just between those relationships will help us to determine what those two quantities are. Okay, so with this high-level understanding, we'll first take a look at a classic type of problem where we only know the sum and the difference between the two quantities. Let's consider this problem. Okay, so Albert has checked out 18 books from a library. So those books are either science books or novels. So in this case, we know the total or the sum of the two types of books. And then the number of size books is 4 more than that of novels. In other words, the difference between the number of science books and the number of the novels is 4. So how many science books and the novels, respectively, did Albert check out? Well, many of you probably know how to work out this problem, but this will be the basis for the next two groups of problems. So we need to give you a very solid understanding of how we're going to solve this problem with only arithmetical method, without any algebra. Even if you know how to solve this problem by algebra, pretend that you do not know. And maybe you also learn how to solve this with algebraic, with arithmetical methods, but this will be a good chance to review that. Okay, for the others, maybe you don't know anything about the algebra yet, or you never even learn how to solve this type of problem. Well, this is an excellent chance for you to learn. So when you were, say, in the second grade or third grade, maybe you have learned to solve this problem with some really visual aid. A typical visual aid would be something like this. We have two quantities. So we denote the larger one like a bar, a longer bar, and we denote the smaller one with a shorter bar, right? So those are the original two numbers. What you were told about this is the sum of the two. Therefore, essentially, you are combining those two bars together. Just you attach the smaller number, the green bar here, to the red bar. And you also learn the difference between the two. That essentially gives you this much quantity, which is kind of the difference between the two. Okay, this is a very good visual aid of what is going on. So these blue ones would be the difference. Let's call it, this is the difference between the large minus the small, right? And the top one, the total combination, we can write it as the sum large plus the small. So how do we figure out the actual large and the small? If we only know this difference, which is right here, we know this quantity, and we know the sum together, which is the total length of this combined bar, something like that. So if we only know those quantities, how do we know the original red bar and the green bar? So with this kind of visual aid, you can see that if we reattach this difference, the smaller green bar, to the very end of the sum, which is the long bar at top, then we will see that because this smaller, shorter blue bar is actually the difference right here. So when you combine this green bar and difference, the total of this is actually exactly the same thing as the length of when you consider from this point to this point, and that is exactly the length of the original red bar. So in other words, the total length here is the length of the red bar, right? So this total length from this point to this point is really 2 copies of the length of the red bar. Therefore, we just show that if we attach this difference shorter bar to the sum of the two, or the longer bar, meaning that if we add this sum and the difference together, then we will get 2 copies of the red bar, which is the larger number. So therefore, this will be equal 2 times large. Okay? So this is really interesting because now we can figure out large is simply the sum plus difference, then divided by 2. So this will be equal the large. Okay? On the other hand, if we go back to where we are, this is the original sum and this is the original difference. If we cut off from the total, the sum, a copy of the smaller or shorter green bar here, right here, the difference, cut off right here. If we cut off the difference from the total, if we cut off that, what would be the remaining portion of the longer bar, the top longer bar? Then we will get actually exactly 2 copies of the smaller or shorter green bar, right? Because this is right here. So if we just cut off this one, which is the difference, then we will see that the remaining portion of the sum would be 2 copies of the smaller, shorter green bar. In other words, if we have sum subtracting the difference, which is this one, we will get 2 copies of the shorter or smaller number. So therefore, we get a formula. If we divide by 2 right here, we will get the smaller quantity. So this is a quite straightforward visual explanation of a general formula. That is that if you know the sum and difference of those 2 numbers, then the larger quantity is just you add the sum and difference together, then divided by 2. And similarly, if you want to get a smaller quantity, you subtract the difference like we did here. We cut off this from the total or the sum, then the remaining will be 2 copies of small, so we divide that by 2, get the small quantity. This is with a visual aid with a bar, with 2 bars showing this type of relationship. However, now at 5th grade, your mathematical maturity should be stronger than say 2 or 3 years ago. So instead of using such visual aid, we can go straight with some algebraic notation. This will be very close to what you will do next year, formally using algebra to solve this problem. But for now, we are still trying to solve it with arithmetical method with some algebraic aid. And we'll see what that is. So let's just write down this relationship as we just did with the bar or bars as the visual aid. We just write down the relationship in English words. So apparently sum is just large plus small, right? And the difference is just large subtracting small. That's the relationship we were given. We know the sum, we know the difference. We just don't know the original large or the small, the original quantity. Now, from this sum and this difference, we want to figure out the original large or small. How do we do it? Well, what if now we add sum and difference directly? With this relationship, you should be able to clearly see that because sum equals to large plus small, and the difference equals large subtracting small. Now if we add them up, so sum and difference would be simply this guy plus this guy, right? That's just straightforward replacing sum with its equivalent right hand side. So we get large, add small, and then add this guy right here. Now we add large minus small. For now, we put a parenthesis here, but you can easily see that this parenthesis is actually unnecessary because we have a straightforward adding. So we are trying to add large plus small, add large subtracting small. We have not formally discussed the associative property when we have subtraction, but you can easily see that we can move this second large closer to the first one. So essentially we swap the adding a small and adding a large to make this add small closer to that one. So now we can cancel out both. So because you add a small and subtract a small, you get canceled. This gives us exactly what we got earlier with the bars as the visual aid. So we get 2 times large. And from this point on, clearly large is this quantity, which is sum plus difference. The sum of the sum and difference, then divided by 2, right? So we got exactly the same result as we saw earlier. And without any doubt, we can do a similar thing on how to get the small. We replace this addition with a subtraction. So now sum subtracting the difference right here would be this quantity subtracting this quantity. Well, you may need a little bit actual to understand this, but it's not that difficult. So this will be large plus small subtracting parentheses a large subtracting a small. Okay, this may present some difficulty because how do we handle this? There's a subtraction here, and inside this parenthesis there's a further subtracting. What you can think about this is that this quantity, large subtracting small, is smaller than large, right? So when we're subtracting them, this result as a whole, we are subtracting a number that is actually smaller than large. So this will be actually equivalent to, we first subtracted the larger number, then add that smaller number back. You will learn this once we learn the negative integers and the related just arithmetical operations. But for now, you can just think about it. I have a number that is subtracting a number which is smaller than this guy by this much. So if you just do a little bit experiment, you will see that this is the same as subtracting this original large number, because it's actually larger than this difference, then add this number that is being subtracted inside back. Okay? So this will be actually as what we did earlier when we subtracting that difference. We got 2 copies of the small. So this will be equal to subtracting the large, then add back that small, which is right here. So we replace this whole thing as this one. Now we see that this is large, this is large. They get canceled out with each other. So at the end, we get 2 small. That is exactly what we got earlier with the bars as the visual aid. If you do not understand this completely, this is okay, because the bars are more direct as a visual aid, and this is much more abstract. But however, at this stage, we are trying to help you get prepared to learn algebra later. So all we did is to replacing those bars, visual bars, with English words. The longer bar is large, the shorter bar is small, and when we add them up, we add them up. When we get the difference between the 2 bars, we use large subtracted small. But if you need further understanding, compare what we are doing to the bar examples. At the end, we still get the same relationship. The difference between the sum and the difference is 2 copies of the small quantity. Therefore, small, the relationship is the small is sum subtracting the difference, then divided by 2. Okay, it just took us this much time to understand a conceptually quite straightforward problem. Let's go back to our original problem. So Albert has checked out 18 books. That's the total of the science books and the novels. And we know he has 4 more books in science books than the number of novels. That's the difference between the science book and the novel books. How do we figure out the number of each type of books? Well, according to what we just analyzed, here, which one is the larger number? It's the number of science books, right? That's what the problem said. It's 4 more than the number of novel books. So that's the larger number. So, according to what we just got, the large number here would be 1/2 of the total, which is 18 here, plus the difference, which is 4 here, divided by 2. That's how we got after a very long analysis. And of course, this is 18 plus 4, that's 22, divided by 2, that's 11 books. Or you can write this as science books. Well, okay. And what is number of the novels? Well, that would be the sum subtracting the difference, which is 4, divided by 2. And this is 14 divided by 2, that's 7 novels. Okay, this is perhaps the simplest sum difference problem you will ever see. In reality, the problem can gradually become a little bit more interesting or more complicated. So let's take a look at another example. So in general, we're still following this kind of analysis. What is the sum plus difference and what is sum subtracting the difference? Okay, next problem. We have an HP printer and the Lexmark printer, two best known brands of printers in the United States. So they can print 7,600 pages in total into 8 hours. But the HP printer can print 50 more pages per hour than the Lexmark printer. So how many pages can either printer print in 1 hour? Okay, so you have to read the problem carefully to make sure you understand what it asks you to do. So we want to know the number of pages that either printer can print in 1 hour. And we have two conditions. One is that together they can print out a certain number of pages in a certain amount of time. Excuse me, what does that give you? It gives you the total of their hourly output, right? This problem is a little bit indirect than the last problem in the sense that we don't know the sum directly, but we do know the sum indirectly, because now if you see that if we divide this 7,600 or 7,600 divided by 8, what is that number? Well, you can see that this is 1,000 minus 50, so it's 950 pages. But you really want to give yourself just kind of a reminder of exactly what the physical meaning of this. This is the combined number of pages that the two printer can print out in 1 hour, right? This is divided by 8. So when you add that unit, you really want to give a very accurate description. This is pages per hour that both printer together can print out in 1 hour. So this is the total of the quantities that we want to figure out. We need to figure out either printer can print out how many pages, and now this quantity is just the sum of those two quantities we are interested in. And then take a look at the second statement. The HP computer can print 50 more pages per hour than the Lexmark. That is the difference, right? This is exactly the difference between the two quantities we need to figure out. So now we know this is just a little bit more complicated problem than the previous problem. We know the sum of two quantities and we know the difference of two quantities. And that sum is right here. It's 950. And what is difference? Difference 50. Now we know by the same formula, the larger quantity of interest must be this sum plus the difference divided by 2. Easily, this is 1,000 divided by 2. So this is a 500 pages per hour. Or you can write a capital H if you will. What is this? This is the printer, higher speed printer, which is HP. The number of pages the HP printer can print out in 1 hour. And what is the other one? It's the smaller one, the slower printer, that is Lexmark. The larger the sum subtracting the difference divided by 2. And this is 900 divided by 2, so this is 450 pages per hour. And this is the another quantity we need to figure out. Okay, so as compared to the first problem, let's just add a little bit twist to the nature of the problem. That is that the sum, the total, was not provided to you directly, but it's not that complicated to figure out. Just one further step. You just need to divide that 7,600 by 8 hours. Okay. Now, let's take a look at a little bit more complicated problem. This time, Aaron and Albert, they have 20 books together. Yeah, you can jump to the conclusion. Yeah, maybe I need to figure out how many books they each have. Yeah, that's correct. But for now, probably you don't want to jump that much ahead. So you want to finish reading the problem. If Aaron gives Albert 6 books, then Aaron has 2 less books than Albert has. How many books do Aaron and Albert each have? Well, this problem just looks a little bit more convoluted because the conditions strange. Yes, they together have 20 books. So we know the sum, which is great. We know the sum. We have 2 quantities and the sum. But the problem did not tell us the difference between the two, right? Instead, it says if Aaron gives Albert 6 books, with this hypothesis, then Aaron has 2 less books than Albert has. What is the actual difference between the two? Well, this problem can actually be solved in 2 ways. One is think about the actual difference between Aaron's books and Albert's books. Because the second condition is not given to you in a direct way, it's in an indirect way, right? If Aaron gives Albert 6 books, then Aaron has 2 less books. So how do we know originally, meaning without this hypothesis, how many books Aaron, the difference between Aaron's book and Albert's book, you can reason backwards, right? Now, after this hypothesis, Aaron has 2 less books. But that's because Aaron gave 6 books to Albert. If we reason backwards, now we know as of right now, Aaron has 2 less books. But that's because Albert took 6 books from Aaron. If Albert gives back those 6 books back to Aaron, then we will restore the original case. In that case, what's the difference between the two? Now you have to think about Albert needs to give back 6 books to Aaron. So Albert will have 6 books less and Aaron will have 6 books more than the current situation. The current situation is that Aaron is 2 books less than Albert's book. So with this reasoning back, Aaron will have 6 plus 6. Let's subtract 2, right? Because one is getting 6 less, one is getting 6 more. In and out, or plus and minus, the net effect of Albert giving 6 books back to Aaron is that their difference should go up by 12. But currently, Aaron has 2 less books. But with this 12 jump, Aaron should have 10 more books than Albert. And this is, we restore the situation to the original real case. So 6 plus 6, this reflects the fact that Albert gives back 6 books to Aaron. So Aaron's net difference will go up by 12, but currently, without this restoration, he's 2 books down. So we will get 6 plus 6 subtracting 2, which is 10. This is the books Aaron actually has more than Albert has. The real situation, right? This is just merely by reasoning back. Because the hypothesis is that Aaron gave 6 books to Albert. Now we reverse that. Albert gives back 6 books. So instead of having 2 less, Aaron should have now 6 plus 6 minus 2, 10 more than Albert has. And this is the reality. So now we know the difference is 10, but Aaron has more books. And what is the total? Total is 20. So now we know how many books Aaron actually has is this sum plus the difference. This is, remember, this is the number that Aaron has more books than Albert has. So this is divided by 2. This gives us 15 books. And don't get confused. This is Aaron's number of books. How many books does Albert have? Of course, it's 20 minus 10 divided by 2. And this is 5 books. If you're not convinced, just imagine what if Aaron now gives Albert 6, then Aaron has 9, and Albert would have 11. That's exactly the situation where Aaron has 2 less books than Albert has. So we solved the problem. Another way to solve this problem is that forget about hypothesis. Yes, we will assume this hypothesis is true. Now we have a new situation, right? This is a hypothetical situation that is different from the real situation. But let's solve the actual numbers they have with this hypothesis. So now what is the current situation? They still have 20 books in total, but Aaron has 2 less books than Albert. Of course, this is with the hypothesis bid. So let's assume this hypothesis is actually there. Now we know this is a straightforward sum and difference problem, right? Because now Albert has more books. Aaron has 2 less. So the new difference here is 2 with the understanding that Albert's number is bigger, Aaron's number is smaller. So that would be that change that to 20 plus 2 divided by 2. This is 22 divided by 2. This is 11 books. What is this quantity? This is the books that Albert currently has with that hypothesis. And our Aaron's number of books will be 20 minus 2 divided by 2. That is 18 divided by 2. That's 9 books. And once again, this is the situation with the hypothesis. But that's not what we want. We want the actual situation. But how do we do that? Now it's quite simple. We just do the reversal. We still reason backwards. Now, Albert has 11, but that's only because Aaron already gave him 6 books. So Albert's actual number of books must be 11 subtracting 6 equals to 5 books. And of course, Aaron's actual number of books is 9 plus 6, which is 15 books. Of course, this matches what we did earlier in this case, but of course, they must be the same. So with 2 different thinkings, we got, of course, the correct result in both ways. But the essence is still the same. You have a sum, you have a difference, how to figure out the larger quantity and the small quantity. Okay, let's get another problem. Well, now, Aaron and Albert own 320 books. They really love to read, don't they? Aaron and Albert own 320 books together. Wait, there's a third guy now. Albert and Alex Who's Alex? Well, just another boy, maybe. Albert and Alex own 240 books together. By the way, Alex can actually be a girl's name. Do you know that? Like Alexandra. So, for now, we assume this is another boy. So, Albert and Alex own 240 books together. But Aaron and Alex own 280 books together. So, we got a quite interesting rotational combination of the three guys. We got three sets of numbers. How many books do they each own? Well, how do we do this? It sounds complicated, but if you think about this very carefully, we know the sum between each pair of boys, right? If this is a sum and difference problem, then we need to know the difference between any two boys, but we don't know that, at least not immediately. But if you think carefully, let's just say between the first number and the second number, what is it? The first number, 320, is the sum of Aaron and Albert's book. The second number is the sum of Albert and Alex's books. If we subtract this second smaller number, 240, from the first one, what is the physical meaning of that? Then we saw just too much difficulty. You can see that this will be actually the difference between what? Aaron's number and Alex's number, right? Why? Because in both cases they contain the number of Albert's book. So when we subtract the second one from the first one, that component got canceled out because each number contains number of Albert's book. So that just the net difference between those two must be exactly the same as the difference between Aaron's book and Alex's book, number of books. So with this understanding now, what should we focus? Well, with this particular subtraction, we should focus on the relationship between Aaron's book, the number of Aaron's book, and number of Alex's number book. And that came in the third one, that is 280. So now we know the sum is 280, but the difference is 320 subtracting 240, that is 80. And which two quantities we are considering right now is the number of Aaron's book and the number of Alex's book. So after figuring this out, we know Alex's number would be a smaller one and Aaron's number would be the larger one. So the number of Aaron, just make sure we understand what we are doing, is 280 plus 80 divided by 2. That's the formula for figure out the larger quantity, right? So this is 360 divided by 2. That would be 180 books. And this would be Aaron's number of books. Similarly, the number of books of Alex would be 280 minus 80. That's 200 divided by 2. That would be 100 number of books. Okay? So this will be Alex. So from this point on, you can either use Aaron and Albert's combination or Alex and Albert's combination to figure out the number of Albert's book. So you can go either way, right? If you choose 320, that's the total of Aaron and Albert, and then subtract the number of 180, so that will be 320 subtracting 180, that's 140 number of books. Okay, so this will be Albert's, or alternatively, you can using 240, that is Albert and Alex combination subtracting Alex number, which you already figure out, that is 140. Sorry, 100. Then you still get 140, the same thing. So 240 is the combination of the Albert's number and Alex number. Subtracting Alex number, you get 140. So of course that's the same thing as here. Okay, so this is purely based on the relationship sum and the difference. Okay, of course, for those of you who really like to think, you can see there's another method, that is that if you add all three numbers up, because this is a pairwise combination, then divided by 2, what do you get? You get the sum of the three guys, the total of the three guys. Now you can subtract each of those numbers from the total, get individual's number. And remember in homework, the previous homework number 4, we actually have such a problem, right? Remember we have the Warriors 3, NBA stars, Steph Curry, Draymond Green, and Klay Thompson, they shoot a free throw. Remember that problem? That's actually exactly what we have here. Very similar concept. But now we are using, just as the example shows, the model is sum and difference. Figure out how to solve it. Now we move on to a new class of problems. And this is a sum and a multiple. Remember at the very beginning we talked about the three relationships and what are those? We have the sum, we have the difference, and we have a third very important relationship, that is the larger number is a multiple of the smaller number. So therefore, if we divide the large number by the small number, we got a multiple. That's the multiple between the two. This multiplicity relationship and is also very important in this type of word problem. And now we see a problem like this, okay? So let's just say there are 80 boys at the elementary school. At that school, each boy will either play basketball or play soccer, one of the two, but not both. So you must play one of the two sports, but you cannot play both. And the number of boys playing basketball is 3 times of that of boys playing soccer. I realize there's a typo here, bear with me, but the number of boys playing basketball is 3 times of the number of boys playing soccer. How many boys play basketball and how many play soccer at this school? This is another classic type of word problem. What are we trying to figure out? We still have 2 quantities, right? One is the number of playing basketball and one is the quantity of the boys playing soccer. But the relationship now is not simply sum. We still have this sum, but not sum and difference. Instead of having a difference, we have a multiplicity relationship. That is, the number of boys playing basketball is 3 times the number of boys playing soccer. So how do we solve this type of problem? Well, if we think about it, what are we trying to get? The 2 relationships, you need to figure them out first. First, we have a multiplicity relationship. So the large number is this particular multiple number times smaller number. That's a given, right? In this case, this multiple is 3 times. So in other words, it's large equals to 3 times small. But at the same time, we also know the sum. So if we, based on this first relationship, if we add the large number and the smaller number up, what will we get? Well, you can see that because the large equals to this multiple times the small. And if we add a small to both sides, the left-hand side becomes large plus small. That's the sum which we already know we need to figure out. We add another small. What happened to the right-hand side? We have a multiple of small plus one more copy of small. With distributed property, you can easily see the right-hand side becomes this multiple number plus 1, right? Then times this small. This is nothing but what we will run as distributed property, but you should be able to see there's a relationship there. The fact that we have add 1 comes from the fact that we are adding one more copy of small. In other words, you already have, say, a multiple copy. Adding one more copy, what do we get? Of course, it's a multiple plus 1 copy of small. And this is actually what we call the distributed property, which when we review arithmetical operations of natural numbers, we will see in a couple of lectures. But for now, it's intuitively very easy to understand why we have multiple plus 1. It's because we are adding one small to the copy. So with this relationship, we can see that the sum of the two numbers, the large and the small, the sum equals 1 plus this multiple times small. Okay, so with this, what shall we do? Well, that's very simple, right? Because now, how do you figure out the small? You just divide this sum by the number of multiple plus 1. So in this case, the total sum is 80. We divide this by the multiple, which is 3 times plus 1. This will give us the smaller number, which is number of boys playing soccer. So this is 80 divided by 4, that's 20. 20 boys, or we can say soccer boys. Well, this is just a notation, right? Soccer boys. That's 20. Okay, of course, the number of boys playing basketball, either you subtracting 20 from 80, you get 60, or you just use that relationship. It's 3 times of the number of playing soccer, so the number of boys playing basketball is simply 60. So you can say this is basketball boys. Okay, so this is how you solve this so-called the sum and the multiple word problem. It's very important to recognize why we can do this. It's based on the fact that 1 is a multiple, the larger one is a multiple of the small. So when we add them up, you just add one more copy. So that's 1 plus multiple copies of small. So we get a multiplicative relationship. And here is the sum, the total, and the small one. And the scalar here, what we call its multiplicity, is 1 plus that multiple. Okay? So this is a very typical type of word problem. Now we will go to a similar type, but now we just learned how to do this type of problem. Sum and the multiple. Now we know there's a different type. This is called the difference and the multiple. Well, conceptually very similar, but this problem takes a little bit more time to decipher. So at elementary school, each girl takes either a choir class or a drama class, but not both. Just like in the previous problem, you cannot do both. Either choir or drama. The number of girls taking the choir class is 26, more than that of the girls taking the drama class. But it's 14 less than 3 times that of girls taking the drama class. That is interesting. Looks a little bit convoluted, isn't it? how many girls take the choir class and how many girls take the drama class. So we have to think about this very carefully. What does that mean? All the conditions came from the second sentence, which contains multiple substatements. So the number of girls taking the choir class is 26 more than that of the girls. So actually we have two numbers, two quantities. One is bigger than the other, and we do know the difference between the two, right? Which number is larger? The choir class number is larger, 26 more than the drama class. But what is the second condition? It's 14 less than 3 times that of the girls taking the drama class. So how do we solve this problem? Well, you first need to recognize that what exactly is the second statement about? It's the number of choir class is 14 less. So this is a difference relationship. But less than what? It's not another straightforward number. It's less than 3 times that of the girls taking the drama class. Okay. Now we have to do something indirect. We will do a hypothesis. Because if we can figure out a hypothetical case, say the number of the girls taking the choir class is increased by 14. If we can figure out that number first, then we can figure out the real number of the girls taking the choir class by subtracting that hypothetical number by 14, right? It's the same relationship. We just do a hypothetical situation. What if now the number of girls taking the choir class increased by 14? What happened then? Then this new number, which is 14 larger than the actual number, would be exactly 3 times of the girls taking the drama class, right? So we have a multiple relationship right here. But this is not between the actual number of choir class number and the drama class number, but a hypothetical new choir class number, which is 14 larger than the original. But how about the first condition? The first condition says that number takes choir class is 26 more than that of girls taking drama class. With this hypothesis, how many more students would be in the choir class? It was 26 more than the drama class. But now with the hypothesis, it would be even 14 more, right? So 26 plus 14 will give us 40. What is this quantity? It's by how many students the hypothetical number of the choir class would be by that many more than the drama class number. So what do we get here? We get a difference relationship, which is 40. The hypothetical new choir class is 40 more than the number of the drama class. At the same time, it's also 3 times of that drama class. This is considerably more difficult than the previous one, but we will get a similar relationship, and that is the larger number is the multiple, in this case 3 times, right? What is the larger number? It's the new hypothetical number of a new choir class. is 3 times of that of the drama class size. At the same time, we don't know the sum, but we know the difference. So the difference between the large and the small, you can see easily by the same logic. We subtract 1 copy of small from the large. So this new multiplicity relationship will be multiple minus 1. Right? Multiple minus 1 because we are subtracting the smaller number from the larger number. Now you get just 1 copy less. Therefore, it's the multiple minus 1 times small. That is the difference. So how do we get the small number? The small number would be this difference, which is now, we know, it's this number 40. 40 divided by this multiple subtracting 1. And what is that? We know the multiple is 3, but we have to subtracting 1, which is the small itself. This is the difference. So 40 divided by 3 minus 1, that's 2. We got 40 divided by 2, that's 20. And what is this? This is the smaller number in those two quantities, which is the actual number of the drama class size. So this is the drama students. Okay? This is the number of the drama students. Now, how do we get the actual number of the quiet class size? Well, we have to times this 20 by 3. That's the multiple relationship 3 times. But remember, this is the hypothetical quiet class size, meaning that we increase the actual by 14. So we have to subtract 14 from this hypothetical one to get the actual quiet class size. So it's 60 subtracting 14. So this is 60 subtracting 14, which is 46. And what is this? This is the actual quiet class size, so quiet students number. Okay, so this is the typical, but in this case it's more complicated because we have to add that hypothetical intermediate step first to convert it into a standard difference and the multiple word problem. So similar to the previous one, previously in the last problem, we know the sum, we know the multiple, we can get the relationship, figure out. In this case, we know the difference, we know the multiple, we still can figure out now. Also in this problem, there's one more intermediate step. So after getting that, we have to reverse that step, which is reflected right here. We have to subtract 14 because that's how we actually convert it into standard difference and sum problem. So those two type of problem, sum and multiple, and difference and the multiple, are kind of symmetrical. The symmetry came from, this is a multiple minus 1, and in the previous case, it's multiple plus 1. One is sum, one is difference. Okay? So today we actually study 3 types of relationship between two quantities. And you can see that the last two, the sum and the multiple, the difference multiple, are actually based on the first type, which is the sum and the difference. Now, the only thing different is that because there's a multiple relationship, we can do distributive property, factor this out. But essentially, the sum and difference relationship is still the same. Okay? It's 4 minutes past the hour, so we got enough. But why don't we do one more problem? If you have other things to do, you can leave and rewatch the tape later. But I think it will be helpful to do one more problem. So Let's do another problem. Okay. So Aaron and Albert, they each have some piggy bank. Does everybody have a piggy bank at home? Okay. So Aaron has $14 more than Albert has in their piggy bank. Aaron is remarkably richer, right? $14 richer. If Albert gives Aaron 6, then the amount of Aaron's money is 3 times that of Albert's. How much money do they each have? Well, remember, this kind of just logically similar to an earlier problem we worked where Aaron gave Albert some books, 6 books to be exact. But now, Albert, if he gives Aaron $6 from his piggy bank, the amount of Aaron's money is 3 times. So based on all the previous problems, we know in this type of problems, we need to add one actual intermediate step. That is that with this hypothesis, if Albert gives Aaron $6, we can either do some reversal at the very beginning, or we can stay with this hypothesis, do what will happen with this hypothesis, then do the reversal. We'll take the second approach because that's logically a little bit simpler. So, if Albert gives Aaron $6, what's the new relationship? Aaron his amount of money will be 3 times as Albert's. So now we know a multiple relationship is 3 times. But what is kind of their difference or sum? Originally, Aaron has $14 more than Albert. Now with this transfer of wealth between the two boys, Albert gave Aaron $6 more. So Albert will be 6 down, and Aaron will be 6 up. But how much money Aaron has more money than Albert? It must be just plus, and you have to double that 6, right? 1 is less, 1 is more. So 6 plus 6, this is the net gain for Aaron over Albert, plus the original 14, 12 plus 14, that is 26. So now with this wealth transfer, Aaron will have $26 more than Albert. And at the same time, his amount of money is 3 times of that. So this is the difference and sum problem, right? And we know in this case, how do we get a smaller number? It's divide this difference, which is now 26, and what is multiple? 3 times. But we have to subtract 1 from this 3, reflecting that we are subtracting the smaller number from the bigger number. So the net difference is 2 multiples because you have subtracted that one, a smaller one. So this is 26, which is the difference, divided by 3 minus 1, that's 2. So it's 13. So $13. And what is this? This is the current amount of money Albert has after he transferred $6 to Aaron, right? At the same time, 13 times 3, that's $39. And this is the current amount of money Aaron has with $6 from Albert. So then how do we know originally each has? We just do the reversal. Either 39 subtracting 6, you get $33. That's what Aaron originally had. And 13 get that $6 back for Albert. So he originally had $19. Okay? So you can verify that 33 minus 19, that's 14. That's the original number, the difference between the two. So this is another typical difference and multiple word problem, and with the intermediate hypothesis right there. Now you know how to handle that hypothesis. You either stay with that hypothesis and figure out the hypothetical numbers, then get a reversal, or you can do another trick by doing the reversal first. But that's usually a little bit more indirect and more complicated, but you can certainly do that. Okay, so in summary, today we have learned a new group of word problems where you have two quantities. They exhibit certain relationship. In particular, we know the sum, we know there's a difference, and we know there's a multiple relationship. Because we only have two unknowns, usually when you know two of those three relationships, you can figure out those two numbers. And that's exactly what we study. We first know the sum and the difference. Then we know the sum and multiple. Then we know the difference and multiple. So in each of those three cases, we were able to solve those quantities. And you will do a lot of fun homework problems as practice. All right, I will see you next week. Bye.